Hello, today we are going through the next part of the Aldenham 2015 maths paper. So without any further ado, let's get straight into these questions. So here for this next question, we have look at the numbers in the start. We have a group of numbers, a set of numbers. Part A asks us which two numbers are multiples of 6. So multiples of 6. Think about your times tables. So we have 6, 12, 18, 24, 30, 36, so on and so forth, right? These numbers are all multiples of 6. So the way we can check that is by seeing if any of these numbers can be divided by 6. Because if they can be divided by 6, that means 6 times something equals that number. And if 6 times something equals a number, that number is a multiple of 6. So 9, no. 10, no. 12, yes, 6 times 2. So we have 12. And we already know here, we're looking for two numbers, right? We have two gaps. So the question is giving us a clue. So let's find the second one. And if you look carefully, it should be 30. Why? Because 6 times 5 is 30. So those are our two multiples of 6. Next one, which two numbers are prime? So you have to know what a prime number is. A prime number is a number that only has two factors, itself and 1, right? It can only be divided by itself and 1. So here, our first prime number should be 17. The only two factors of 17 are 17 and 1. And then our second prime number should be 29, right? Because 29 again only has two factors, itself, 29, and 1. So 29 is our second prime number. So now let's move into part C, and now we have which two numbers are factors of 60. So we've already gone through multiples, but what do we mean by factors? Well, a number will be a factor of 70 if 70 can be divided by that number and it leaves no remainders, right? So if we have 8, for example, and we divide 8 by 4, then since 4 times 2 is 8, we have a clean number. It's 2, no remainders. But if we try and divide that same 8 by 5, look what happens. Yes, 5 goes into 8 once, but then we have a remainder of 3. So the answer here would be 1 remainder 3. So whenever we have this remainder situation, that tells us that the number, 5 in this case, is not a factor of the other number. So here we're looking for factors of 70. And again, our times tables can help us, because if we use our times tables, we know the first one should be 10, right? Because 10 times 7 is 70. Or rather, 70 divided by 10 gives us 7, remainder 0, no remainders. So our first one should be 10. And what about our second one? Well, let's go through the numbers. It's not going to be 12, right? Because 12 times 5 is 60. Then add 12 again is 72. However, 14 looks very promising because 14 times 5 is 70. 14 times 5. 4 times 5 is 20, so 0, carry the 2. 5 times 1 is 5, plus the 2 we carried over is 7, so 70. So if 14 times 5 is 70, that means 70 divided by 14 should give us 5, remainder 0, no remainders. Therefore, it's a factor, so 14 here. And finally, we have which two numbers are square numbers. So numbers that are square numbers, let's find it. The first one's going to be 9. Why? Because 3 squared is 9, and therefore 9 is a square number. And then also we have 49. Why? Because this time 7 squared is 49. So our two numbers, which are square numbers, are 9 and 49. Very big question there, but that's how we work it out. So here for this next question, let's be very careful with how we work it out because there are a couple of traps laid for us. So let's go through it. George had a bag full of 24 apples and he gave half of them to his granny to make an apple pie. Then he gave 2/3 of what was left to his friends and then put the rest in the fruit bowl. So how many did he put in the fruit bowl? So let's start by going through the first bullet point. He gave half of his 24 apples to his granny to make an apple pie. So half of 24, we know of, the code word of that is times, multiplication. So half times 24 over 1, or 24, same thing. Here, we can work out how many apples this equates to, how many apples he gave to his granny, because we can simplify this equation by cancelling along this diagonal. Why? Because we have a common factor of 2. 2 goes into 2 and it also goes into 24. It goes into 2 once and into 24 12 times. So here we have 1 over 1 times 12 over 1 or just 12. So he gave 12 to his granny. Then bullet point 2, he gave 2/3 of what was left, which would be 12 apples, to his friends. So how many did he give to his friends? 2/3 of 12. Well, divide by this diagonal here, we have a common factor of 3. 3 goes into 3 once, into 12 4 times. So we have 2 over 1 times 4 over 1, or 2 times 4, 8. So he gave 8 to his friends. He didn't keep 8, he gave 8 to his friends. And that's important because it tells us we need to subtract 8 from the 12 he originally had to work out the rest that he has in his fruit bowl, because that's what the question is concerning. How many did he put in the fruit bowl? So it's 12 minus the 8 he gave to his friends, giving us 4 apples. So George put 4 apples in his fruit bowl. So here for this question, the whole point is to turn this text into maths. And if we can do that accurately, the answer should pop out. So let's try and work this out. Emily is thinking of a number, and let's call that number X. What does Emily do to X? Well, first she adds 2 to it. She adds 2 to X. So we have X plus 2. Then she squares everything. So very important here. She's not squaring X. She's squaring everything, X plus 2. So we need some brackets and we're squaring everything. And then she subtracts 4 and she gets 60. What number was Emily thinking of? To work out what number she was thinking of, we need to work out X. And to work out X, we need to end up with X on one side of the equal sign, on one side of the equation, and a number on the other side of the equation. So what do we need to do? We need to rearrange the equation. So let's get into this equation. And the right mindset to have is we know we need to end up with X equals something. So X on one side and the number on the other side. So what we need to do is remove all the obstacles blocking us from getting to X on its own. So the first obstacle is this subtraction by 4. So we can take that out or reverse it by adding 4 to both sides. So adding 4 to both sides gives us X plus 2 squared on the left-hand side and 64 on the right-hand side. Then we can square root both sides. Left-hand side, we have X plus 2. Right-hand side, we have the square root of 64, which is 8, because 8 squared is 64. Let's bring this up here so we have a bit more space. X plus 2 equals 8. Well, now we can subtract 2 from both sides. Let's put it in a nice bold red. And this gives us on our left-hand side what we wanted, x. And on the right-hand side, we have 8 minus 2, which gives us our magic number of 6. So now we know the number that Emily was thinking of is, or was, 6. So now we have to circle the smallest number in each group. So let's start with A. Well, straight away, we know to look at the tenths column, right? Because this number here, 0.309, is going to be bigger than this number here, 0.039, because in the tenths column we have 3, and here in the tenths column we have 0. So using this understanding, we can already disqualify this number here. And also we can disqualify 0.93. So let's move on to this final one. We have 0.093. So here for both of these numbers in our tenths column, we have a 0. So now let's move on to the hundredths column. Here we have a 3, but here we have a 9. Now, because 9 is bigger than 3, this number here is going to be bigger than 0.039. And therefore, 0.039 is the smallest number. So this is how you work out the smallest number when you have decimals. It's not about which number has the most or the least number of numbers after the decimal point. It's more about going through the number step by step by going through the tenths column, hundredths column, thousandths column, so on and so forth. And this leaves us with our answer of 0.039. Let's make it nice and neat. 0.039. So now for part B, we have minus 7.5, we have minus 8, 2 and 0. So here the smallest number is going to be minus 8. Make sure you're very careful with this because we have this negative number. So therefore we're going in the negative direction. So as the numbers seemingly get bigger, they're actually getting smaller, right? Negative 1,000 minus 1,000 is smaller than minus 1. So here the smallest number is minus 8. Then for part C, the smallest number is going to be 1 over 8. And that's because if you understand what fractions actually mean, a fraction is simply a division. We're dividing the numerator, the top number, by the denominator, the bottom number. So the bigger the bottom number the denominator gets, the more pieces, the more slices we're cutting the numerator, the top number into. Think about it like a pizza. If you're at the restaurant with your friends and you have a whole pizza between two of you, you're each going to get a pretty good slice, right? You're not going to be too hungry. But if you share the same pizza, but you've brought 10 of your friends or 20 of your friends, you will leave that restaurant very, very hungry. Why? Because you split that one pizza into 20 slices rather than splitting it into 8 slices or 2 slices. So you can see as the number on the bottom, the denominator, gets bigger, the size of your pizza slice gets smaller. So here the smallest number is 1 over 8, an eighth. And now for part D, we have a mixture of fractions, decimals, and percentages. So first and foremost, we can cancel out 0.4. Let's not even think about it because we already know 0.22 is smaller than 0.4. So then we have 1/4, 0.22, 30%. Let's turn these all into fractions. That's the easiest thing to convert them into. And also the easiest thing to compare. So 30% is going to be 30 over 100. 0.22 is going to be 22 over 100. And 1/4 is going to be 25 over 100, right? We multiply both the numerator and the denominator by 25. So now they all have the same common denominator. it's very easy to compare the numbers because all we do is compare the numerators, and the smallest numerator is 22. And therefore 0.22 is the smallest number. Okay, so that is all for today. Make sure you like the video, subscribe, and turn on notifications so that you're the first to know when the next video is released. And on that note, I will see you all next time.